This is Biddeford High School Graduation Standard A4.2 Systems of Equations. And for this standard, it should be somewhat of a review of the Algebra 1 version of A4.1, which is also named Systems of Equations. Okay? So if we think back to Algebra 1, a system of equations is a set or a collection of points that we deal with at one time. Okay, so what this ultimately means is our variables represent the same numbers. Okay, so the only major difference between A4.2 and A4.1 is that in A4.2 we will also be dealing with nonlinear systems and linear programming problems. So for A4.2, the level 3 of the standard is the ability to solve 3 variable systems of equations, whereas that is the level 4 for A4.1. Okay, so we know we are dealing with a systems of equations problem when we are given two or more equations that use the same variables. Okay, these variables, as we just said above, have identical values. And if you need more time, please feel free to pause the video. Okay, so again, some more general formatting. Oftentimes, two or more equations will be grouped together using a single brace. And of course, I don't know anybody who is good at drawing them, but it looks just like that. Okay, with one equation up here, another equation down here. And again, we could have 3, 4, 5, as many as equations as we want. Okay, so let's look at an example of a system of equations problem. Okay, so I'll put y plus 4x equals 8 and 5x plus 2y equals 13. Okay, and of course, in this system, we have an x here, an x there. Okay, x will represent the same number. Okay, so if x equals 2, if we figure that out, then x equals 2 up here, it also equals 2 down here. Okay, and the same thing for the y's. So what do systems of equations problems tell us? Okay, they tell us solutions of variables. Okay, So we'll be dealing with three different types of solutions. So if we look at a graph and the lines cross, okay, that tells us we have one solution. At the intersection point. Okay, so if we have two lines that cross at the point 2, 3, okay, so x equaling 2 and y equaling 3, we know that's our solution. Okay, so let's say these two lines, I don't think they do, but let's say they cross at the ordered pair 10, 4. Okay, x equals 10, y equals 4. That means for both equations here, x would equal 10 and y would equal 4. Okay, our next scenario, the lines never cross. So I'll put in parentheses what this actually means. It means they're parallel. If they're not parallel, they will eventually cross. Okay? So if the lines never cross, that means we don't have an intersection point. Okay? So this means there are no solutions. So if our lines never cross, let's go back and look at the system up here. That means there's not one point we can plug in for x and one point we can plug in to y to make both of these equations true. Okay? So if we were to plug in a 1 for x and a 2 for y, okay, maybe that satisfies this bottom equation right here, but it will not satisfy this top equation. Okay? So our last scenario, our lines are the same. Okay? And of course that could happen. So if our lines are the same, they intersect at an infinite amount of points. Okay? At every single location they are intersecting. Okay? So this tells us that there are infinitely many solutions. Okay, pause the video if you need more time. Okay, so here's where we get into some of the problems. Okay, really not any level 1 problems. They pretty much start with number 2, or level 2. Okay, so for level 2, you will, of course with a little practice, be able to solve a system of two equations using more than one of the methods listed below. So we have substitution, elimination, and Cramer's rule. Okay, I know some classes or some teachers do not teach Cramer's rule. I will get into it a little bit later once we get there, but I am going to teach it because I believe it is important. Okay, so let's look at substitution first. Okay, so the substitution method works by solving for one variable in one of our equations whoops, there we go, sorry about that. and then plugging whatever that variable equals into our other equation. Okay? So let's move down here. Okay? So let's take a look at what we just wrote as we're going through this problem. Okay? So y equals x plus 1. This will be my first equation. Okay? So we need to solve for one of our variables in one of our equations. Okay? So we pick this as our first equation, so we're going to solve for a variable in this equation. The beauty about this system right here, y is already solved for. Okay, so that makes our life a lot easier. Okay? And something to note right now, let's say we have a system where one of our variables is not solved for already. We're going to come to a situation where we have to pick a variable to solve for. So when we are picking that variable, we are going to want to pick the variable that has a coefficient of 1 or negative 1, because we won't have to multiply or divide by some number other than 1 or negative 1, because if we do that, we'll be left with a fraction. And of course, we can deal with fractions with these problems, but that is not ideal. Okay, so just to continue on, because this is a system, we know y equals x plus 1 from this first equation, okay, y equals x plus 1, and negative 4x plus 11. Okay, because y equals x plus 1 up here, and y equals negative 4x plus 11 down here. Okay, so y equals this, and y equals that. Okay, so by following our instructions above, okay, because y equals x plus 1 and y equals negative 4x plus 11, okay, so y equals this and y equals that, that must mean that x plus 1 equals negative 4x plus 11. Okay, and if that's not clear, let me do this. So we know these y's are equal. Okay, because those y's are equal, y equals this, and y equals this right here. Okay, so we could set these y's equal to each other. Okay, y equals y, of course, that makes sense. Okay, but since y equals this and y equals that, we're going to set those two things equal to each other. So x plus 1 equals negative 4x plus 11. Okay, then we're just going to solve. So I'll add 4x Okay, so negative 4x plus 4x, that cancels. I'm left with 5x plus 1 equals 11. Subtract 1 over to this side, so I have 5x equals 10. Okay, so x equals 2. Okay, so we solve for one variable. So we are going to go back up to our system here, pick one of our equations, and plug this x equals 2 in. Okay, so wherever I see an x, I'll replace it with a 2. And then that way we will be able to solve for y. So I pick whichever one looks easiest, so I'll pick this first one up here. So I'll write y equals, I have an x, so I'll put 2 plus 1. Okay? So we know that x equals 2 and y equals 2 plus 1, which is 3. Okay? We can write it like this, or we could also write it as an ordered pair. We could even write it with braces. Again, as long as we get the correct numbers, that's what I'm most concerned with right now. Okay? Pause the video if you need more time. Okay, so does it matter which variable we solve for? Okay, well, let's try it out. So let's solve for x instead. Okay, so I'm going to use this first equation right here. Okay, so let's say I subtract this one over to this side. I'd have the x by itself. So x equals y minus 1. Okay, I'll just put it in parentheses here. This is my first equation. Okay, so now I will plug this expression into our second equation. Okay, so I think using color helps emphasize this point. So for this x right here, we know that it equals y minus 1. So I'm going to take this expression, because I know x equals this, okay, they are the same, and I'm going to plug it in right here for that x. Okay, so let's take a look at that. So I have y equals negative 4. Been using red, so I'll keep using it. Y minus 1 plus 11. Okay, so I have the second equation. Instead of plugging in x, I plugged in what x equals, which is y minus 1. Okay, so now we distribute. So I have y equals negative 4y plus 4 plus 11. Okay, so if I add 4y over here, I get 5y equals 4 plus 11, which is 15. Okay, so obviously y equals 3. Okay, so from here, Go right up here. Okay. We can plug this in. Our first or second equation. Okay, so our options here, we can plug that y equals 3 up here, we could plug it down here, we could actually even plug it in right here because this equation is the same as this top one, we just shifted it around a little bit. Okay, so I'll use this top equation again, looks easiest. So put this 3 in parentheses here, show that it represents y, equals x plus 1. Okay, we subtract the 1 over to get x by itself, x equals 2. Okay. And again, x equals 2, y equals 3, that's exactly what we got in our example above. Okay, so it doesn't matter, going back to this question, does it matter which variable we solve for? No, it does not. Pause the video if you need more time. Okay, so does it matter which equation we use? No, it doesn't. And to elaborate on this, we could have solved for either variable in either equation and still get x equals 2, y equals 3. Okay? And on your own time, we're not going to do it during this video, but give it a try. Okay? And if you do not get x equals 2 and y equals 3, you know you messed up somewhere. Okay? So let's take a look at these two examples right here. Okay? Look at this one first. So we have y equals negative 2x plus 6. Okay? So y, they're the same. And it equals negative 2x minus 6, and y equals 4x plus 12. Okay? So what I'm going to do, since y equals negative 2x minus 6, and y also equals 4x plus 12, I'll set these two expressions equal to each other. So I have negative 2x minus 6 equals 4x plus 12. Okay, so let's do some math. I'll subtract the 4x over here. So I have negative 6x minus 6 equals 12. Okay, to get this expression by itself, I'll add 6 over to this side. So I have negative 6x equals 12 plus 6, which is 18. So x equals negative 3. Okay. So now, at this point, I'm going to pick one of these two equations and plug in x equals negative 3. Okay? So I'll pick this top one up here. So y equals negative 2. Instead of x, I have negative 3 minus 6. Okay, so to simplify this, y equals positive 6, negative 2 times negative 3, minus this 6. So 6 minus 6, y equals 0. Okay? So that's our solution right there. X equals negative 3, y equals 0. Again, does it matter which variable we solve for? No, but y was already solved for us. Okay? Does it matter which equation we use? No, not at all. Okay? It's a system, so the point is to get the same solutions for both variables. Okay? So let's take a look at this one over here. I have y equals this. Okay, so we know those y's are the same. So y equals x minus 3, and y also equals 3x minus 11. So y equals y, of course, so I'll set these two expressions equal to each other. So I have x minus 3 equals 3x minus 11. Okay, so let's do some math. I'll subtract this 3x over to this side. So x minus 3x is negative 2x. Minus 3 equals negative 11. Okay, I'll add this 3 over. So I have negative 2x equals negative 11 plus 3, which is negative 8. So that leaves me with x equals positive 4. Okay. So again, I'll take this x equals 4. I'll pick an equation up here. The top one looks the most appealing right now. So y equals 4 minus 3. Okay, so instead of x, I just plugged in 4. So y equals 4 minus 3, so y equals 1. Okay. Alright, let's take a look at these ones right here. Okay, so these ones are a little bit tougher. Okay, we don't have a variable that's isolated currently in either equation. Okay, so as I was talking about earlier, when we're doing substitution, we need to get one of those variables by itself. So what I first look for, I don't want to deal with fractions if I don't have to. So I'm going to try to look for a variable that has a coefficient of 1 or negative 1. Because then I know I won't have to divide by a whole number and have an equation full of fractions. So, looking right here at these four terms, this y down here has a coefficient of 1. Okay? So I'm going to try to get that y by itself. So, I'll subtract this 6x over. So I have y equals negative 6x minus 5. Okay? Or you could have negative 5 minus 6x. It doesn't really matter. Okay? So now that I have y equaling this, I'm going to take this negative 6x minus 5, go up to my top equation, and plug it in right there. Okay? So I get negative 7x plus 2. I'll plug in my y term because y equals this. Negative 6x minus 5 equals positive 9. Okay, so I'll distribute right here. So I have negative 7x minus 12x minus 10 equals 9. Okay, so I'll combine. So negative 7x minus 12x, that's negative 19x. I'll add this 10 over, so equals 9 plus 10, which is 19. So I know that x equals negative 1. Okay, so I'll take this negative 1, I'll pick an equation up here, and I'll plug it in. So let's try this top one. Okay, so negative 7, write my negative 1 in parentheses, plus 2y equals 9. Okay, so I get positive 7 plus 2y equals 9. subtract the 7 over. So I have 2y equals 9 minus 7, which is 2. So y equals 1. Okay, so that's my solution right there. X equals -1, y equals 1. So just to reiterate that graphing part, if we were to graph these two lines, okay, put them in slope-intercept form and graph them, they would cross at the point x equals -1, y equals 1. So the ordered pair -1, 1. Okay, so let's try this last example up here. Or last example for now. So I'm going to look at these four terms. I know I'm using substitution. -2x, I don't really want to deal with that -2. This 3 I don't really want to deal with. This -7 won't make our equation look any prettier. But this y has a coefficient of 1. So I'm going to solve for that y. So I'll add 2x over here. So I have y equals 2x minus 11. Or you could have -11 plus 2x, doesn't matter. Okay, so I know y equals 2x minus 11. So I'm going to take this 2x minus 11 and plug it in for y down here. Okay, so I have 3x minus 7 2x minus 11 equals 22. Okay, so I'll distribute here. I have 3x minus 14x plus 77 equals 22. Okay, so I'll combine 3x minus 14x is -11x. Okay, I'll subtract the 77 over, so 22 minus 77 equals -55. So I know x equals 5. Okay, so I'll take this x equals 5, I'll plug it into one of these two equations. I'll pick the top one this time. So -2 parentheses my 5 instead of my x plus y equals -11. Okay, so -10 plus y equals -11. I'll add 10 over to get rid of this -10 over onto this side. So -11 plus 10 equals -1. Okay, so that's my solution. These lines would cross at the ordered pair 5, -1. Okay, so let's move right on to our next strategy, which is elimination. Okay, so let's think about how we would solve a one variable equation. Okay, so I have the example here, a minus 6 equals 10. Okay, so to solve this, make my t-chart here, we would add 6 onto this side and add 6 onto this side. Okay, so -6 plus 6, those would cancel. We're left with a equals 10 plus 6, which is 16. Okay, so we're basically doing the same thing when we are using elimination. Okay, we are trying, instead of eliminating a number, we are trying to eliminate one of our variables. Okay, so pause the video if you need more time. Okay, so by using the elimination method, as I said, we're basically doing the same exact thing, okay, except we are eliminating a variable. Okay, so let's see how this would look with two variables. Okay, and as I said way back at the beginning of this video, okay, we will use elimination as well when we are solving three variable systems during level 3. Okay, so let's take a look at these right here. Okay, so I'm going to draw a line. Okay, and I'm going to combine these two equations. Okay, so I like to make sure they're lined up like this. Makes life easier. So I have 4x plus 3x. Well, we know that equals 7x. Okay, I have plus y minus y. Well, if we have plus 1y and we're subtracting 1y, that equals 0. So those cancel out. Okay, then I have my equals, negative 17 minus 4 is negative 21. So here, x equals negative 3. Okay, so what we're going to do now, just like we did with substitution, we are going to pick an equation and plug in our solved variable. Okay, so I'll pick this bottom one right here. Okay, so 3 parentheses, I know that x equals negative 3. Okay, minus y equals negative 4. So 3 times negative 3, that's negative 9 minus y equals negative 4. Okay, I'll add 9 over to this side. So I have negative y equals negative 4 plus 9 is positive 5. Okay. To get this y by itself, we need to divide by negative 1, or we can just bring the sign over here. So we know that y equals negative 5. So that's our solution right there. So that was an easy one. Our variables cancel, or one of our variables canceled out rather easily. Okay? So what if nothing happened, or nothing appears to cancel out right away? Nothing happens to cancel out. We must scale our equation or equations. Okay, so let's see what that would look like. So first we need to analyze our equation. Okay, so we have 3x plus y equals negative 7, and we have 6x minus 4y equals negative 8. So ideally, just to make the math simple and to save some time, I'm going to pick a variable first, and I'm going to pick an equation that only needs to be scaled once. Okay, so if we take a look at these two equations, if we were to pick our x, we could multiply this top equation by negative 2. That would get us the opposite of 6x. That would give us negative 6x. So that could work. Or we could pick the y. If this y were positive 4y, it would cancel out with this negative 4y, and we'd be all set. Okay? So again, it does not matter which variable we take. I'm going to pick this one. Okay? So I'm going to multiply this entire equation, or scale it, by 4. I'll bring it right down here. So 4 times 3x is 12x. 4 times y is a positive 4y. And 4 times negative 7 is negative 28. There we go. So I have negative 4y plus 4y. I'll cross that right out. 6x plus 12x, that is 18x. And negative 8 minus 28, That is negative 36. So here I know x equals negative 2. Okay, so now I need to pick an equation and plug in this x equals negative 2. I will choose this bottom one. So I have 6 times negative 2 minus 4y equals negative 8. Okay, so let's do some math. We have negative 12 minus 4y equals negative 8. I'll add the 12 over. So I have negative 4y equals positive 4. So I know y equals negative 1. Okay, so pause the video if you need more time. So, does it matter which variable we cancel? Just like substitution? No. We will get the same results. Okay, and does it matter which equation we scale? No. As long as we can cancel a variable, we are all set. Okay? In fact, as I hinted to earlier, sometimes we may have to scale both of our equations. Okay? Pause the video if you need more time. Okay, so let's solve these 4 problems right here. Okay, so switch up the color a little bit. Okay, so analyze my equations. Looking at this, x's won't cancel, but our y's will. We have a positive 3y and a negative 3y. Okay, so immediately those cancel because 3y minus 3y equals 0. Okay, 4x plus x is 5x, and negative 1 plus 11 equals 10. So x equals 2. Okay, so now that we have one variable solved for, we need to pick an equation and plug in this x equals 2. Okay, so let's pick this bottom one. So 2 minus 3y equals 11. So I'll subtract this 2 over. So negative 3y equals 9. 11 minus 2. So I know that y equals negative 3. Okay? So let's go to this equation right here. So I have negative 7x minus 7x. So those don't cancel because they have the same sign. And we have a negative 2y and a positive 6y. Okay? So what I'm going to do, if this were a positive 7x, I would be able to cancel these x's right here. So how am I going to do that? I'll scale this equation by negative 1. Okay? I'll bring it right down here. So I have, oops, let me get rid of that line right there. So I have positive 7x now. Negative 1 times negative 2 is a positive 2y. Okay, negative 1 times negative 19 is positive 19. Now I can eliminate. So negative 7x plus 7x, that cancels. 6y plus 2y, that equals 8y. And 29 plus 19 is 48. So I know that y equals 6. Okay, so pick an equation now. I will pick, let's do this top one up here. So negative 7x minus 2, instead of my y I have my 6, equals negative 19. Okay, so just to simplify, negative 7x minus 12 equals negative 19. Okay, so I'll add this 12 over, so I get negative 7x equals negative 19 plus 12 is negative 7. So I know x equals 1. Okay, let's move down to these ones right here. So first off, I need to pick a variable. So I have 16x and 8x. Okay, if this down here were a negative 16x, that would cancel. And I have 6y and 2y. So if this were negative 6y, this would cancel. So it doesn't really matter which one we pick. I will multiply this one by negative 2. Okay, and I'll just write it right below. So I have negative 16x minus 4y equals negative 4. And I'll take this top equation and I'll just put it right underneath. So I have 16x plus 6y equals negative 2. Okay. So now I can eliminate. Negative 16x plus 16x cancels. Negative 4y plus 6y is 2y. Negative 4 minus 2 is negative 6. So y equals negative 3. Okay. So now I'm going to take this y equals negative 3 and plug it into one of the equations. Okay, I'll pick this bottom one right here. So I have 8x plus 2, my negative 3 in place, equals 2. Okay, so just to simplify, 8x minus 6 equals 2. I'll add 6 over. 8x equals 8. So I know x equals 1. Okay. So again, just to reiterate this point, if we were to graph these two lines, they would intersect at the point 1, negative 3. Okay? Alright, last one. So for this equation right here, 4 and 3, there's not one equation we can scale to get those equal to each other. Same thing with negative 8 and 9 for our y's. So now we have to pick a variable because we need to scale both equations. So what I'll do, I'll pick this x right here. So I know 4 and 3 are both factors of 12. So I'll multiply this top equation by negative 3. I'll multiply this bottom equation by 4. Okay? Or you can multiply this one by negative 4 and this one by positive 3. Doesn't matter as long as you get them to eliminate. Okay? So I'll rewrite these over here. Okay, so my top one, I have negative 12x. Negative 3 times negative 8 is positive 24. And I have negative 3 times negative 8 again, so I have positive 24. My bottom one right here, I have 12x. 4 times 9 is 36. course, my y comes along, and 4 times negative 6 is negative 24. So now I can eliminate. Negative 12x plus 12x cancels or eliminates. 24y plus 36y. That equals 60y. And 24 minus 24 is 0. So, divide by 60 on both sides, I get y equals 0. So now I'll pick an equation. I'll pick this bottom one right here and plug in 0 for y. So 3x plus 9 times 0 equals negative 6. So to simplify, I have 3x. This is 0, so I'll just leave it out. Equals negative 6. So I know x equals negative 2. Awesome. Okay, pause if you need more time. Okay, so last but not least, we have Cramer's rule. Okay, so I like to teach this because I never learned this when I was in high school, and then I ended up going to college and taking a course called linear algebra, which had a lot of matrix math, which is what we'll get to, which essentially is what Cramer's rule is. And we dealt a lot with Cramer's rule. Also, I think it's important because maybe you don't like substitution, maybe you don't like elimination, maybe you don't like graphing. You always have this fourth option up here. Okay? So, let's take a look at it. So, we need to learn some new vocabulary. So, matrix is an array of numbers enclosed by square brackets. Okay? The numbers are the coefficients in our system. So again, this is all notation right here. So using a matrix allows us to organize information without our variables. Okay, so below are some examples of systems of equations put into matrices. Okay, and of course matrices is just the plural form of the word matrix. Okay, so I'll first plug it in with variables. So I have 5x. I'm just going to go right in order. So I have 5x minus y. So I have 5x, and I have minus y. And down in the second equation, I have negative 7x and positive y. Okay, so I'll just put y. Okay, so now I just need the coefficients of these terms right here. So I'll have 5 up here, negative 1 up here, negative 7 down here, and 1 down here. Okay, so that's perfect right there. That's a good looking matrix. So over here I'll do the same thing. Negative 6x and 7y. Down here I have negative 6x. And I have minus 5y. Probably should have made those matrices a little bigger. What do you think? Okay, so now just take the coefficients. Negative 6, 7, negative 6, and negative 5. Okay, perfect. So now we're going to talk about determinants, which are a little hard to explain. But a determinant is an array of numbers enclosed by two vertical bars. Okay? So a determinant, we need to solve for determinants or find determinants in order to use Cramer's rule. But outside of Cramer's rule and in matrix math, determinants are just a useful value that we can use. I know that when we are trying to find the volume of solids, the determinant is a very useful strategy that we can use. But besides that, I once had a college professor who really had a hard time describing exactly what a determinant was. So me not being a college professor with a doctorate in mathematics, this will be very hard for me to explain. So if you still have questions over what a determinant is, I can do more research. Of course, you can do your research, and we can talk about it. But for right now, we are just going to call it a useful strategy that we use in matrix math, okay, to help us solve systems using Cramer's rule. Okay? So it is a useful value that can be computed from the elements of a square matrix. Okay, pause the video if you need more time. Okay, so to find determinants. So if we have a generic matrix, okay, my square brackets here, labeled A, B, C, D, then the determinant, it's kind of like a cross multiplying scenario here. Okay? We have the determinant equaling A times D minus B times C. Okay? So if we're finding the determinant of these matrices below, okay, I have, whoops, cancel that. Again, let me rewrite this, AD minus BC. Okay, I have 4 times 3 minus 2 times 1. Okay, so doing some math here, I have 12 minus 2. Of course, that equals 10, which is our determinant. Okay, we'll do the same thing exactly over here. Okay, I have negative 2 times 3 minus 5 times 4. And it is very important to put these values in parentheses, just because this minus sign or the subtraction sign throws a lot of people off. Okay? A lot of people end up adding when they're supposed to subtract, or subtracting when they're supposed to add. So I just find it breaks it down. It takes 5 extra seconds just to put everything in parentheses so we organize everything. Okay? So negative 2 times 3 is negative 6. My minus sign, 5 times 4, which is 20. So my determinant is negative 26. Okay? So, if we use Cramer's rule, we'll need to find 3 determinants. We'll name these matrices D, E, and F. So if we had just a generic system of equations, okay, we would have A1x plus B1y equals C1, and A2x plus B2y equals C2. So what this just means, okay, we have our variables, our x's right here, our y's right here, okay, and we have A1, B1, C1, A2, B2, C2, okay. A1 and B1 and A2 and B2, those are just coefficients. So these are just numbers. C1 and C2, they are also just numbers. Okay? So it turns out that matrix D would be A1, A2, B1, B2. Okay? And E would be C1, C2, B1, B2. Okay? And F is A1, A2, C1, C2. Okay? So this is what we're trying to do. We need to find the determinants of these 3 matrices. Okay? So to find our x equals the determinant of E divided by the determinant of D. Okay? And Y turns out to be the determinant of F divided by the determinant of D as well. Okay? So, just to explain the process a little bit better, we have our system. Okay? We take the coefficients in the order they're in. Okay? So A1, B1, C1, A2, B2, C2, and plug them into these matrices. And of course, we label them D, E, and F. Okay? So once we have them in this form, we need to find the determinants. So we do AD minus BC. So, for example, the determinant of D would be A1 times B2 minus B1 times A2. Okay? So then we get that value, that determinant of D, and it would be our denominator for x and y. Okay? So let's look at an example. Okay, so let me switch up my color here. So first off, I'm going to label all my points. So A1 is my coefficient right here, so it's 1. A2 is my coefficient down here, it is also 1. B1 is my coefficient right here. It's positive 7. B2 is my coefficient right here. Positive 2. C1 is this value right here, negative 8. And C2 is my last value right here, happens to be 2. Okay, so now I'm going to fill in my matrices. So matrix D equals, I know up top it's A1, B1, so 1, 7. And then it is A2, B2, so 1, 2. Okay, I know E is C1 up here, which is negative 8, and B1, which is 7, and C2, which is 2, and B2, which is also 2. Okay, one more. So F equals, no, it's A1, C1, so I have 1 and 2, and A2, C2, so I have 1 and 2 again. Actually, sorry, quick mistake there. I said C1 was 2 right there, but as we can see, C1 is negative 8. Sorry about that. Okay, and down bottom here, we have A1, C2, which is 1, 2. Okay, so now we need to find the determinants. So right up here, I'll write determinant of D, okay, and it equals, change my color, I'll make my lines. So I have 1 times 2 minus 7 times 1. Okay, so I have 2 minus 7, which equals negative 5. Okay, so I'm just going to star this value because I'll need it for later. So, determinant of E equals negative 8 times 2 minus 7 times 2. Let me write that down. Negative 8, 2, minus 7, 2. Okay, so I get negative 16 minus 14. So that equals negative 30. So I'll star that as well. Okay, my last one, write it over here. Determinant of F equals, draw my lines, negative 1 times, or not negative 1, positive 1 times 2, minus negative 8 times 1. Again, everything in parentheses. So I have 2 minus negative 8 times 1 is negative 8. So 2 minus negative 8, that's the same thing as 2 plus 8. So that equals 10. So I'll start that as well. So now I have all three determinants. Now I can solve for x and y. So now I'll write this in a different color. So x equals determinant of E divided by determinant of D. So determinant of E is this negative 30 right here, divided by determinant of D, we said is negative 5. So x equals 6. Okay, and y equals the determinant of f divided by the determinant of d, which equals 10 divided by -5. So y equals -2. So we used Kramer's rule and found that x equals 6, y equals -2. If we were to use substitution, we get the same answer. If we were to use elimination, we get the same answer. And if we were to graph these, we'd see that they cross at the intersection point 6, -2. Okay, so let's do this last example down here, and then we'll call it good. So just above, I'll label all these points. I have A1, B1, C1. I have A2, B2, and C2. Okay, so I'll make matrix D. So I have A1 and A2. So I have 3 and 5. And I have B1 and B2, -2 and -3. Okay, I'll make E. So E, we have our C's in the first column, so -1, -3. Okay, and our B1 and our B2, so -2, -3. And I have F, which is A1, A2 in our first column. So I have 3, 5, and C1, C2 in my second column. So I have -1, -3. Okay, so now I need to find the determinants of all of these. Okay, so again, I kind of do this cross multiplying thing and subtract them. So I'll do D first. So determinant of D equals, I have 3 times -3 minus -2 times 5. Okay, so 3 times -3, that's -9, minus -2 times 5, put in parentheses here, -10. So this equals -9 plus 10, which happens to be 1. Okay, so I'll star this, just so I remember it for later, don't lose track of it. So determinant of E is -1 times -3 minus -2 times -3. Okay, so I get +3 here, minus, and I have -2 times -3, well that's +6. So 3 minus 6 is -3. So I'll start so I don't lose track. Last but not least, we have determinant F. Okay, so for determinant F, we have 3 times -3 minus -1 times 5. So -3 times 3, that's -9, minus -1 times 5, that's -5. So I can rewrite this as -9 plus 5. So that equals -4. So I'll star that one as well. So let me change color here. Again, almost done. So x equals determinant of E divided by the determinant of D, which equals negative 3 divided by positive 1. Okay, so x equals negative 3. Okay, and y equals the determinant of f divided by the determinant of D, which equals negative 4 divided by 1 again. So y equals negative 4. So again, if we used elimination, we would find that x equals 3 and y equals negative 4. Whoops. If we use substitution, we would find that x equals negative 3 and y equals negative 4. And if we were to graph these, we would see that these lines intersect over here at the point negative 3, negative 4.